Okay, how are you guys? Today we're going to look at revision of a Cambridge International AS and A level uh, pure mathematics paper 3 for May June 2022, which was 1 hour 50 minutes long. So we're going to solve this paper. For number one, we're given a problem. Solve the equation 2 times 3 to the power 2x minus 1 equals to 4 to the power x plus 1. So what we are supposed to do here, taking our problem, 2 times 3 to the power 2x minus 1, like this, equals to 4 to the power x plus 1. So what we have to do is to first get rid of the 2 on this side, but to do that, what we have to do is to first express 4 as 2 to the power 2, then times x plus 1, like that. So after that, yet this is equals to 2 to the power 2x plus 2, like 2 times x, 2x plus 2 times 1, 2. Now that we have 2 times 3 to the power 2x minus 1 equals to 2 to the power 2x plus 2. So now we divide by 2 both sides. So this 2 and that 2 cancels out. Then on this side, we now have 3 to the power 2x minus 1 equals to, by laws of indices, since we have 2 to the power 2x plus 1 over 2 to the power 1, so since we have division, we subtract the powers, so it means we are going to have 2 to the power 2x plus 2 minus 1, which means we have 3 to the power 2x minus 1 equals to 2 to the power 2x plus 1. When we reach this stage, we apply ln both sides. So we're going to have ln 3 to the power 2x minus 1 equals to ln 2 to the power 2x plus 1. This is since, since ln to the power a, ln a to the power b equals to b ln a, this implies that we can write this as 2x minus 1 ln 3 equals to 2x plus 1 ln 2, like that. Then after that we expand the brackets, so we have 2x ln 3 minus ln 3 equals to 2x times ln 2, so 2x ln 2 plus 1 times ln 2 ln 2, like that. Then after this, we continue. So from here, we collect terms with x on one side without on the other side. So we are going to have 2x ln 3 minus 2x ln 2 equals to ln 2. We take minus 3 to the other side, becomes plus ln 3. Then from this side, we factor out x. We remain with 2 ln 3 minus 2 ln 2 equals to ln. Remember, ln a plus ln b equals to ln ab. So this is the same as ln 2 times 3, which is ln 6. Then on this side, again, we have x times ln 3 to the power 2 minus ln 2 to the power 2. This is from this rule, which is equals to ln 6. And then this simplifies to x ln 3 squared, that's 9, minus ln 2 squared, that's 4, equals to ln 6. Also, we know that since ln A minus ln B equals to ln A over B implies here we're going to have x ln 9 over 4 equals to ln 6. So to remain with x, we divide by ln 9 over 4 both sides. So this and that cancels out, and our answer becomes ln 6 over ln 9 over 4. We can also write this as ln 6 over ln 2,25, like that. Since we are told that our answer should be to 3 significant figures, let us evaluate. So if we punch on a calculator ln 6 divided by ln 2,25, we get this. Our answer is 2,21. 2, 3 significant figures. Then we are done. So this is the solution for number 1. We then move on to number 2. So for number 2, we are asked to expand 2 minus x squared then to the power minus 2. So first we have to use the rule. We have to use the rule 1 plus, which says that 1 plus x to the power n equals 1 plus n x plus n times n minus 1 x squared over 2 factorial plus n times n minus 1 times n minus 2 x cubed over 3 factorial and so on plus dash dash. So what we're going to do is first we want to have 1 here, so we factor out 2. So it means we're going to have 2 bracket 1 minus x squared over 2 all to the power minus 2. So it means that this is 2 to the power minus 2 times 1 minus x squared over 2 to the power minus 2. Yet 2 to the power minus 2, that is 1 over 2 squared, which is 1/4. Then in bracket we now expand. We expand whilst holding 1/4 outside the bracket. So we expand using this rule. So we're going to have 1 plus. This is our x is here, and our n, the power, is minus 2. So it means we're going to have 1 plus nx, so that is 1 plus n is minus 2 times minus x squared over 2 plus n, that is minus 2 times n minus 1 minus 3 times x squared, which is minus x squared over 2 squared over 2 factorial. Remember, we are asked to expand up to a term in x to the power 4. Yeah, you can see that we have minus x squared over 2 then squared. So this term will give us x to the power 4. So we're going to end here. So we put this bracket. So from here, we have our 1/4 outside. Now, this is 1 minus 2 times minus x squared. This 2 and 2 cancels out, negative and negative cancels out, so we remain with 1 plus x squared. Then from here, 2 factorial is just 2, so 2 into 2, 1, 2 into minus 2, we remain with minus 1 there. So now minus 1 times minus 3, and that will be positive 3. And then, so we're going to have plus 3. Then this bracket, if we say minus x squared over 2 squared, we get x to the power 4 over 4. Then times 3, so it becomes 3x to the power 4 over 4, like that. So this will give us the expansion. So finally, we multiply by 1/4 throughout. So we're going to have 1/4 plus 1/4 x squared. 1/4 times 3/4 x to the power 4, we get 3 over 16 x to the power 4. So this will be our final solution, and I hope it's clear. So from there, we then move on to the last part. The last part reads, state the set of values of x for which the expansion is valid. So if we have 1 plus x to the power n, if we have the expansion for that, the expansion is valid for modulus of x less than 1, for modulus of x less than, in fact, less than or equal to 1, like that. So what it means is, from our question, from this question, let us look at, we have 1 minus x squared over 2. So taking this as our x, so we are going to have modulus of minus x squared over 2 less than or equal to 1, which implies that we have modulus of x squared over 2 less than or equal to 1, multiplying by 2, both sides we are going to have modulus of x squared less than or equal to 2. Taking positive square roots, both sides we are going to have modulus of x less than or equal to root of 2. So in short, that is the set of values will be minus root 2 less than x less than square root of 2. That will be our solution again, and I hope that was clear. So now we move on to number 3. Number 3, the question reads, solve the equation 2 cot 2x plus 3 cot x for x 0 less than x less than 180 degrees. So first we have to reduce the equation so that it will be in terms of, let's say, tan x or cot x. So from 2 cot 2x, it means this is 2 over tan 2x plus 3 over tan x equals to 5. But what is tan 2x? What is tan 2x? So you can see that tan 2x equals to 2 tan x over 2 tan x over 1 minus tan squared x. So we have to make use of that. So where there is tan 2x, you are going to replace with the identity for tan 2x. So it means we are going to have 2 over 2 tan x over 1 minus tan squared x plus 3 over tan x equals to 5. So from there, to have a 2 divided by 2 tan x over 1 minus tan squared x, that is the same as 2 multiplying the reciprocal of this fraction. So it will be 2 times 1 minus tan squared x over 2 tan x over 2 tan x, and then plus 3 over tan x equals to 5, like that. So now multiplying throughout by 2 tan x to get rid of my denominators, the lowest common multiple of the denominators is 2 tan x. So we multiply throughout by 2 tan x. So we multiply every term by 2 tan x. So we say times 2 tan x times 2 tan x, then times 2 tan x again on the first term. So this and that cancels out, tan and tan cancels out. So on the first term, what it means is we are going to have 2 bracket 1 minus tan squared x plus 3 times 2, that will be 6, equals to 2 times 5, that will be 10 tan x, like that. So we then divide throughout by 2 and take everything to one side. So we're going to so taking everything to one side, after doing that, so here we're going to have 3, there we're going to have 10. So taking everything to one side, we're going to have tan squared x plus 5 tan x. This is the 5 tan x. Then here we have 1. So 1 plus 6. 1 plus 6, that's 7. So if we take 7 to this other side, sorry, here we have we divided by 2 and we have 3. So 1 plus 3, that will be 4. And we take 4 to the other side, it becomes minus 4. Then equals to 0. So we have tan squared x plus 5 tan x, then plus minus 4, because we have plus 4 to the other side becomes minus 4, equals to 0. Like that. Now we have a quadratic equation, and we don't have factors of minus 4 that give us 5. So what we have to do is we have to use the quadratic formula to solve this equation. So what we are going to do is we are going to first let's say let a be equal to tan x. So it means we are going to have a quadratic equation a squared plus 5a minus 4 equals to 0, which means a equals to minus b. So coefficients, our coefficients are a, b, c. So the coefficient of this middle term is 5, so it's minus 5 plus or minus square root of 5 squared minus 4 times a, that's 1, times c, that's minus 4, then over 2 times 1, it remains 2. So this is minus 5 plus or minus square root of. So this is 25, then plus 16 over 2. So we have a equals to minus 5 plus or minus square root of 41 over 2, which implies that we have we now replace tan x, a by tan x. So we're going to have tan x equals to minus 5 plus or minus square root of 41 over 2, i.e. tan x equals to minus 4. So let us just reduce it to a decimal form. So if we say minus 5 plus square root 41 close bracket divided by 2, the first one will give us 0, 0.7, 0, 0, 2 to 3 significant figures, or tan x equals to the second one. Now taking the one with a negative sign in between, so we're going to have minus 5 minus root of 41, then divided by 2, and we get minus 5,70, minus 5,70 to 3 significant figures again. Okay, so after doing this, now we are going to find all the solutions which are in the interval 0 less than x less than 180. So what we are going to do is we take the first one. We're going to look at tan x equals to 0,702, and we look for solutions for that one. So we're going to find the solutions. We're going to use the rule to find all the solutions in the interval. We're going to use the rule which says that x equals to, this is for tan theta. For tan theta, we're going to use x equals to PV plus 180n, since we are using degrees. So PV will be the initial solution which we get when we say tan inverse of 0,702. So we call it the principal value. So second function turn. So I have let me check. My calculator is giving me false readings. Right, so we have 0,702. If we say second function turn 0,702 equals to second function turn, right, we have 35,1 degrees. So it means we have our PV equals to 35,1 degrees. So it means our solutions for this equation, it means we have x equals to, where there's PV, we now put 35.1 plus 180 m. So for n equals to 0, it means this becomes 0. We have x equals to 35,1. For n equals to 1, we have this becomes 180 plus 35. We get x equals to 180 plus 35. That will be 315,1. 215,1. So x equals to 215,1, which is out of the range. So we discard it. So it means in the range 0 to 180, we only have x equals to 35.1 as our solution. So we move on to the next equation, which is tan x equals to minus 5,70, and we look for solutions for that equation again. So we have minus 5,70. Second function turn, we get so it means we have our PV being equal to minus 80,0 degrees, minus 80,0 degrees. So substituting into our formula, where there's PV, we put minus 80, then plus 180. So after writing this equation, for n equals to 0, it means that this part will be 0. So x equals to minus 80,0, which is not in the range 0 to 180 degrees. So we look for n equals to 1. It means we have minus 80 plus 180. So that will be x equals to 100 degrees. So if we do this, then we are now done. So it means our solutions are x equals to, which are in the range. You can see that x equals to 100 is in the range 0 to 180. So it means our solution is said to consist of x equals to 35,1 degrees and x equals to 100,0 degrees, like this. Then we are done. And I hope this was clear. So next, we move on to the next question, which is number 4. So as for number 4, we were given the variable x and y satisfy the differential equation, and we are given the condition, and we are asked to solve the differential equation, obtaining a simplified expression for y in terms of x. So from this, we have dy over dx equals to xy over 1 plus x squared. So we rearrange using separation of variables. So if we do that, it means we are going to have dy over y equals to x over 1 plus x squared dx. So now integrating that, so we now want to integrate dy over y equal to integral of x over 1 plus x squared dx. So if we integrate dy over y, that will give us, or this is 1 over y dy, will give us ln y equals to Here, if we differentiate 1 plus x squared, we get 2x, and because we have the value is x here, we factor out half there. So this is now f prime over half, which means our answer is half ln 1 plus x squared, then plus c. After this, we then substitute the initial condition which we are given. So we are given that y equals to 2 and x equals to 0. So where there's y, we put 2. So we have ln 2 equals to half ln 1 plus 0, which is 1 plus c. But ln 1 is 0. So what it means is c equals to ln 2. Then, which means our answer will be ln y equals to half ln 1 plus x squared plus ln 2, which is ln y equals to ln 1 plus x squared to the power half is the same as ln square root of 1 plus x squared, then plus ln 2. Then combining the right hand side, it means we have ln y equals to ln 2 times the square root of 1 plus x squared, like that. This is since ln a plus ln b equals to ln ab equals to ln ab. So applying exponent both sides, we then get y equals to 2 square root of 1 plus x squared. Then that will be our final answer. So after this, we then move on to number 5. There are no problems. We are given a polynomial a x cubed minus 10 x squared plus bx plus 8. So this polynomial is denoted by px. It's denoted by px. So we are told that it is given that x minus 2 is a factor of both px and p prime of x. So what you're going to do is, first you're going to find p prime of x. So p prime of x equals to 3ax squared minus 20x plus b. So what you're going to do is, alright, so since x minus 2 is a factor of p of x and p prime of x, so what you're going to do is, what it means is, since x minus 2 is a factor, what it means is p of 2 equals to 0, and also p prime of 2 equals to 0. So we're going to make use of that. So first, p of 2 equals to a 2 cubed, that will be 8a, minus 2 squared, that's 4 times 10, that will be minus 40. Then plus 2b, then plus 8. Then p prime of 2 equals to 2 squared, that will be 4 times 3, 12, so we have 12a, and then 2 times minus 20, that will be minus 40, then plus b. So we know that this is equal to 0. We're told that that is equals to 0. So we now group like terms. So it means we're going to have 12a plus b equals to 40. And from the first equation, we have 8a plus 2b equals to minus 40 plus 8, that will be minus 32. Taking it to the other side becomes positive 32. So this is what we have at the moment. Then from this second equation, we can divide throughout by 2. So if we do that, our set of equations, we have 2a plus b. At 12a plus b equals to 40, and 4a plus b equals to 16. Now, since we have coefficients of b being the same here, now we're going to subtract. We are going to solve this as simultaneous equations and by a method of elimination. So 12a minus 4a, that would be 8a. Then b minus b 0 equals to 40 minus 16, that will be 24. We divide by 8 both sides and we get a equals to 3. So we have a equals to 3. To get b, we can take, say, this equation. We're going to use that equation where there is a. So it means we are going to use 4a plus b equals to 16. So where there is a, we're going to put 3. So 4 times 3, that will be 12. So it means b equals to 16 minus 12, which is 4. So as our answer, it means a equals to 3, comma, when b equals to 4. Then we are done. So that will be the solution for number 5a. Now we want to move on to 5b. We want to look at 5b. So as for 5b, we are told that when a and b have these values, factorize px completely. So we are going to first write px with values of a and b. So a is 3, so it means we have 3x cubed minus 10x squared, then plus b is 4, so plus 4x plus 8. So as our polynomial. So we're going to factorize this. So first we're going to use long division we're going to divide this, since x minus 2 is a factor, we're going to divide by x minus 2 using long division to get the other quadratic factor. So x into 3x cubed, we get 3x squared. 3x squared times x, that will be 3x cubed. 3x cubed times minus 2, that would be minus 6x squared. Then we subtract. So 3x cubed minus 3x cubed is 0. Minus 10x squared minus it becomes plus. So minus 10x squared plus 6, it becomes minus 4x squared. Now, x into minus 4x squared, we have minus 4x. Minus 4x times x, minus 4x squared. Minus 4x times minus 2, we have plus 8x. Then here we bring down plus 4x. This plus 4x, we bring it down there. So we then subtract again. So minus 4x minus 4x is 0. 4x minus 8x, that would be minus 4x. Then x into minus 4x, we get minus 4. Minus 4 times x, minus 4x. Minus 4 times minus 2 is plus 8. Then we bring down plus 8 again here. Subtracting the 2, we get 0. So it means this is the quadratic factor. Now factorizing that. So we have 3x squared minus 4x. We are told to factorize completely. So 3 times 4 is minus 24. Factors of minus 24, that give us minus 4, minus 6 and 4. Minus 6 times 4 is minus 24, minus 6 plus 4. Let me start again. So 3 times minus 4, that would be minus 12. Factors of minus 12, that gives us minus 4 are minus 6 and 2. Sorry about that. Minus 6 and 2. So it means we are going to have 3x squared minus 6x plus 2x minus 4. So this will be 3x bracket x minus 2 plus 2 bracket x minus 2. So this simplifies to 3x plus 2 times x minus 2. Now px in a factorized form and being factorized completely, px equals to x minus 2 times x minus 2 times 3x plus 2, which is x minus 2 squared times 3x plus 2. So this is now the factorized form of px. So we then move on to number 6. So as for number 6, and use substitution x equals to 3 tan theta to show that I equals to that. So first we have x equals to 3 tan theta. We need the expression for dx, so it means dx equals to 3 sec squared theta d theta, like that. Then these are the limits for x, so we want to find the limits again for theta. So what it means is, where there is x, let us put the lower limit. So we have 0 equals to 3 tan theta. 0 equals to 3 tan theta. So dividing by 3 both sides, we still have tan theta equals to 0, which means theta equals to 0. Then we have 3 equals to 3 tan theta. Dividing by 3, we get tan theta equals to 1. So tan inverse of 1 gives us theta equals to pi over 4. So we now have our limits. Now substituting, so we have integral of 27 over 9 plus x squared, then squared dx. So this is equals to 27 times, where there is dx, we put 3 sec squared theta d theta over 9 plus, and then x is x squared, it's 9 tan squared theta, like that. So what we're going to do is 9 tan squared theta, then squared again, like that. So what we're going to do is we're going to factor out 9, and if we factor out 9 and we square, we have 27 times 3, that will be 81 sec squared theta d theta, then over. If we factor out 9 and square 9, we get 81. Then we remain with 1 plus tan squared theta squared d theta. But what is tan squared theta there? Tan squared 1 plus tan squared theta, it's sec squared theta. So 81 and 81 cancels out. 81 and 81 cancels out, and 1 plus tan squared, it's sec squared. So what it means is we have integral of sec squared theta, then d theta over sec squared theta, then squared, like that. So this reduces to integral of 1 over sec squared theta d theta, of which this is equals to, this is 1 over cos squared. So this is just integral of cos squared theta d theta, and the limits we have already calculated them, are from 0 to pi over 4 as desired. I hope that was clear as well. So now we want to look at finding the exact value of that integral. So now integrating the integral of, we want to find the integral of cos squared theta d theta from 0 to pi over 4. That is what we are going to look at. But for the moment being, we have the identity. Cos 2 theta equals to 2 cos squared theta minus 1. This is the identity we are going to use. We are going to make cos squared the subject, the formula. So it means if we take minus 1 to this side, it becomes plus 1, and we divide by 2. So we are going to have 1 plus cos 2 theta over 2 equals to cos squared theta. So what it means, instead of integrating cos squared theta, we now integrate that. So what it means, this is equals to the integral of 1 plus cos 2 theta over 2 d theta from 0 to pi over 4. This is equals to, we can factor out half so that we only remain with 1 plus cos 2 theta d theta from 0 to pi over 4. Yes, so this is half bracket theta. If we integrate cos, we get sine, then we differentiate and divide by 2, so this is theta plus half sine 2 theta, then from 0 to pi over 4. Yes, so this will be half, then in bracket, if we put pi over 4, we now have pi over 4 plus a sine, where there's theta, 2 times pi over 4 is pi over 2. So sine pi over 2, that will be 0 times half, it remains 0. Minus, we now put the lower limit. If we put 0 there, we have 0 plus sine 0, it's 0 again. So what it means is, this is pi over 4 plus 0, just inside the whole bracket, we only remain with pi over 4 times half, so we have pi over 8. And pi over 8 will be our answer in this case. So now we're going to look at number 7. Number 7 reads, a complex number u is defined by u equals root 2 minus a root 2i over 1 plus 2i, where a is a positive integer. Express u in terms of a in the form x plus yi. So we have to, this is in rational form, we have to simplify it to reduce it so that we remove this fractional form. So what we do is we multiply by the conjugate of the denominator on the numerator as well as on the denominator, and then we simplify. Okay, so root 2 times 1, that will be root 2 times minus 2, so it becomes minus 2 root 2i. Now this multiplies the whole bracket again, so minus a root 2 times 1, we have minus a root 2i, then a negative times negative, that becomes plus, plus a times 2 root 2i squared, then over 1 minus 4i squared. So this becomes, so here where there is I squared, that becomes a negative. So we now have root 2 minus 2a root 2 as our real part, then minus root 2 in brackets 2 root 2i. Let us also factor out root 2i in bracket 2, then plus a, like that, then all over 5. So what it means is we have, root 2 in brackets 1 minus 2a over 5 minus root 2 times 2a plus then I, then over 5 again. So this will be our answer for number 7. We can just cross check. So we have root 2 minus 2 root 2i, then we have minus a root 2i, then plus 2a 2 root 2i squared, which then becomes a minus here. And then we, after doing that, we factored out root 2 to remain with 1 minus 2a here, and there we factored out root 2i to remain with 2 plus a. Yeah, I think that's okay. So we move on to the part B of number 7. We are told that a equals to 3. We are told that a equals to 3. So if a equals to 3, it means we have u. If a equals to 3, what it means is we have u equals to 1 minus 2 times 3, that will be 6. So 1 minus 6 is minus 5. Over 5 we remain with minus root 2. Then this is when a equals to 3 is the condition in which we are given there. Now on this part, substituting 3, since a is 3 here, substituting 3 in the expression for u here. Now later, if we put first, we placed 3 here to get 6. 1 minus 6, it gave us minus 5. So minus 5 over 5, we remained with minus root 2. So now we put 3 there. So 2 plus 3 is 5 over 5. We only remain with root 2. So it means but we have a minus there. So it means we have minus root 2i. So this is what we now have. So we now have u equals to minus root 2 over minus root 2 minus root 2i, like that. So after doing that, after doing this, we then find the magnitude of u. So magnitude of u will be r, will give us r. So modulus of u equals to square root of minus root 2 squared plus minus root 2 squared. So this is square root of so minus root 2 squared will give us 2. Minus root 2 squared will give us 2. So this is 2 plus 2, which is square root of 4, which is 2. So it means we have r equals to 2. Now theta equals to the tan inverse of minus root 2 over minus root 2, which is pi over, this is tan inverse of 1, which is pi over 4. So it means z equals to 2 e to the power pi over 4i. So this will be our complex number, and I hope it's clear. Okay, part C. Using your answer to part B, find the 2 square roots of u, giving your answer in the form r e to the I theta, giving your answer in the form r e to the I theta. So we now want to look at part C. Now we look at part C. So using your answer to part B, find the 2 square roots of u, giving your answer in the form r e to the I theta. So that is what we are now going to look at. So our u is okay. Right, so we are looking for the square roots of u. So okay, so this is supposed to be u. So square root of u will be equal to 2 e to the power over 4i, then to the power half. So in short, this will be equal to root 2 e to the power pi over 4i plus 2 pi k over 2, like that. So in short, we are looking for a new solution. Root of u, let us call it w. We are going to the solution, we will call it the solutions w. So since we have multiple solutions, we are going to use this iterative formula wk. So for k equals to 0, w naught equals to root 2 e to the power pi over 4 I plus 0. So when k equals, if we put 0 there, so it means we only remain pi over 4, then divided by 2, so it becomes pi over 8 I. So when k equals to 1, we have w1 equals to root 2 e to the power so when k equals 1, we have 2 pi. So this will be 2 pi times 1, it remains 2 pi plus pi over 4. So this will become e to the power 9 pi over 4, then divided by 2, so 9 pi over 8 I. So these will be the two solutions to that. So this is how we obtained the solutions. So next we are going to look at number 8. Then after number 8, we look at number 9. So first, let us look at number 8. So as for number 8, we were given in this equation, and we are supposed to look for dy dx for that equation. So if we differentiate the equation, if we differentiate the given equation, our dy over dx, to get dy over dx, we are going to do it implicitly, using implicit differentiation. So we just differentiate the equation. So if we differentiate x cubed, we get 3x squared plus 3y squared dy over dx. Remember, when you differentiate an expression in y, you multiply by dy dx. Then plus, we differentiate with respect to x, we get 2y. Then plus, we differentiate with respect to y, we get 2x dy over dx. We use the product rule here. Then we differentiate a to get 0, so equals to 0. Differentiate 0 is to get 0. Now we group terms with the dy dx on one side without on the other side. So we're going to have 3y squared plus 2x times dy over dx equals to minus 3x squared minus 2y. We divide by this bracket, so we get dy over dx equals to minus 3x squared plus 2y. We factored out the negative, then divided by 3y squared plus 2x. So this will give us the solution. The tangent to the curve at the point when x equals to 0 and the tangent at the point when y equals to 0 intersect at an angle alpha. Find the value of tan alpha. Find the value of tan alpha. Okay, so when x equals to 0, if we substitute the value of x in this equation for x equals to 0, we get the gradient of the tangent when x is equal to 0 in dy dx. So when x equals to 0, also we need to find the corresponding value of y. That is also important. So in the original equation, if we substitute in the original equation, remember our original equation is x cubed plus y cubed plus 2xy plus 8 equals to 0. We are going to make use of that equation. So substituting x equals to 0, we remain with y cubed plus 8 equals to 0, which means y cubed equals to minus 8. Taking cube root, we get y equals to minus 2. Now we are also told, all right, so for this point, so it means we have our coordinate is 0, -2. Now for y equals to 0, for y equals to 0, substituting y equals to 0 in this equation, we're going to get x cubed, then plus 8 equals to 0, which means x cubed equals to -8. Similarly, we get x equals to -2. Alright, so our coordinate again becomes -2, 0. So we are going to find the equations, let's say the gradients of the two tangents. So for 0 minus 2 dy over dx equals to, where there's x we're going to put 0, where there's y we're going to put -2, so we're going to have minus 2 times -2, that's -2 times negative 2 times -2, that's -4 times negative, becomes 4, over where there is the x we put 0, then we have -2 squared, that will be 4 times 3, we have 12, so this will be -1/3. Then 4 -2, 0, dy over dx equals to, we substitute, where there is y we put 0, where there is x we put -2, so 3 times -2 squared, that will be 12, times negative, we have -12, over, now where there's y we put 0, so 2 times -2, we have -4, so it means we have 3 here. So these are the gradients of the two tangents. Now let us call the first one m1, the second one m2. Now m1 times m2 equals to -1/3 times 3, which is -1. Therefore, which means therefore the two tangents are perpendicular. That is what we have to first note. So if they are perpendicular, it means the angle between them is 90 degrees. The angle between them is 90 degrees. The angle between them is 90 degrees. That is what it means. Okay, so since the angle is 90 degrees, it means the tan alpha goes to infinity over L. We move on to number 9. Okay, so we are now on number 9. So as for number 9, we are given a diagram, and the question reads, in the diagram, OA, BC, DE, FG is a cuboid in which OA equals to 2 units, then OC equals to 4 units, OA equals to 2 units, OC 4 units, OC is 4 units, then OG is 2 units. So unit vectors NG are parallel to OA, OC, and OG respectively. The point N is the midpoint of DF. Okay, so the point N on AB is such that AN equals to 3 NB. The point N on AB, alright, AN equals to 3 NB. Okay, so express vectors OM and MN in terms of IJ and K. So first, OM, the vector OM equals to OM. So to get to OM, there, so what it means is we can go, we are told that M is the midpoint of DF. So if it is the midpoint, so to get to OM we can do this. it means we are going to move vertically upwards, and then we move to this point like that. So we are going to move from O to this point, which is at the middle, which is a middle point there. Then from this point, so it means in the ith direction, since OA is 4 units, alright, let us do it this way. In the jth direction, we start from the jth direction. So OC, we are told it's 4 units. So up to the middle point, it means we moved 2j in the jth direction. Now we are moving upwards here. And we are told that OG is how many? It's 2 units. So again, it's in the positive direction, so plus 2. That is the kth direction, so plus 2k. Now from here, going in this direction, again we are told that OA, we are told that OA is 2 units. So since OA is 2 units, it means, and we are moving in the positive direction with respect to OA, so it means OA is 2 units, so it means we are moving halfway up to the midpoint, so it will be plus I. So in short, OM equals to I plus 2j plus 2k. So that will be the position vector for OM. So we now want to look for ON. We now want to look for ON. Anyway, so for MN, so for MN, it means we are going to say MO plus ON. We are going to say MN, we can use MO, then plus ON, MO plus ON. So what is ON? But first, ON equals to OA plus AN. So we said ON equals to OA plus AN. So we are looking at ON. So this is equals, what is ON? ON. We said OA plus AN, and OA is what? OA is 2, so it's 2I. That's OA plus AN. We know that AN equals to 3NB. AN equals to 3NB. So what it means is we have 4 parts there. So AN equals to 3/4, which is 3/4 of what? Of AB. 3/4 of AB, which means we have 2I plus. This is 3/4 of AB. It's 4 units. But it's AB and OC are the same. So since there are 4 units, 4 times 3/4, we get G, 3, then J, like that. So that will be ON. So it's 2I plus 3J, which makes sense because we haven't moved vertically or in the direction of K. So it means now we have MN being equal to OM. This is 1, 2, 2, 1, 2, 2 minus, right, we said OM, this is MO, so it will be negative, then plus ON, it's 2, 3, then 0, like that. So this is the same as say 2, 3, 0 minus 1, 2, 2, and this gives us what? 2 minus 1, 1, 3 minus 2, 1, 0 minus 2, minus 2. So what it means is MN equals to I plus J minus 2K, like that. Find a vector equation for the line through M and N. So the equation, let's say we write it as OM, then plus lambda MN, plus lambda mn, which is OM equals to 1, 2, 2 plus lambda mn is 1, 1 minus 2. Then we're done. Then C, show that the length of the perpendicular from O to the line through M and N, show that the length of the line from O to the line through it's 2 plus lambda minus 1. Times this. Tan is alright. Sorry, tan equals tan 150. Half x equals 2. Okay, so we have half x equals to tan pi minus x. If you check, tan 30 is equivalent to minus tan 150. So in short, tan pi minus x is equivalent to minus tan x, like that, which verifies the rule that the solution converges to the root of the equation in part A. And then we are done. Okay, use the iterative formula given in part C to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Give the result of each iteration to 4 decimal places. So what you're going to do is we're going to use, you have to make sure that your calculator is in the radian mode. So you have to change it to radians for these iterations. So we have our iterative formula is here, xn plus 1 equals to pi minus tan inverse of half xn. Is okay. Right, so we are not really given the initial value. So what we do is all right. So our root, we know that our root lies in the interval 0 to pi. 0 to pi, and we are not given the initial value. So what we are going to do is okay, since in part B we have showed that the root lies between 2 and 2,5, we can use the midpoint. We can approximate using the midpoint of 2 and 2,5 because we know that it is in between 2 and 2,55. So as our initial solution, let us assume at the midpoint of 2 and 2,5, which is 2,25. So we are going to take x naught be equal to the midpoint of 2 and 2,5. We get it by saying 2 plus 2,5 over 2, which is 2,25. So now for x1, we are going to use the calculator to do that. I'm going to use the sharp version. So from the equation, we have pi, then minus, pi, then minus, second function. Okay guys, so what we have to do is we are going to use the calculator to find the other solution. So the first thing you do is you type your initial solution, 2,25, 2,25. You just say equals to, and then you leave it like that. Then you type your equation to say pi minus second function tan in brackets 0,5, that's half. You can use half, but I prefer 0,5. Then instead of x, you say recall answer, so that it will be picking it will pick our initial answer. So to get x1, it will pick the previous answer. So like here in this case, it means our first root will be 2 comma. I remember we are told to leave our answers to 4 decimal places. So 2 comma 2974 to 4 decimal places. So for x2, since the formula is there, where there is answer, it will pick the current solution. So it will pick x1 to evaluate x2. So we just press again equals to. So we're going to have 2 comma 2871. For x3, it used x2 to evaluate x3. So it means for x3 we have 2,2893. Then for x4 equals to 2,2888, like that. So the question said, use the iterative formula in part C to determine a correct to 2 decimal places. So correct to 2 decimal places, you can see that our solution here, if you round it becomes 2,29. If you round this one up, it becomes 2,29. Here it becomes 2,29. So it means to 2 decimal places, our solution is 2,29. So this will be our solution for part B. Alright guys, so this is the end of our paper. I hope it was clear and we managed to do the whole paper. So if you have any questions, any queries, please feel free to leave to comment or email me on gabrielsam714 at gmail.com. It is also given on the description of the video on YouTube. Please like, share and subscribe. Please feel free to comment. Please feel free to share. Support so that we continue providing these videos. Thank you very much. Have a good day.